Present, sir.
65,
Present, sir.
66, Ajay
Sir,
Chaturvedi.
Arjun Sankar present, sir.
Okay. 67,
Present, sir.
70,
Present, sir.
71,
Present, sir.
72,
Present, sir.
73, 773, Anushka.
Absent, sir.
75,
Present, sir.
76,
Present, sir.
78,
Yes, sir.
79,
Present, sir.
80,
Present, sir.
84, 784, 85,
Present, sir.
86,
Present, sir.
87,
Present, sir.
89,
Present, sir.
90,
Present, sir.
91,
Present, sir.
92,
Present, sir.
97,
Present, sir.
99,
Present, sir.
98,
Present, sir.
801, Kartika Patel, 802,
Present, sir.
804,
Present, sir.
806,
Present, sir.
807, 807,
Present, sir. Neha, she is in the.
नेहा प्रेजेंट है नेहा वाजपेयी
Yes, sir. Present, sir.
Yes, sir. Yes, sir.
808
Present, sir.
810
Present, sir.
11 Ramchandra 811 absent 12
Present, sir.
14 Priyesh
Present, sir. 14.
15
Present, sir.
16
Present, sir.
17
Present, sir.
18 Rishabh Prasad 19 819 Ritika Singh present है 21
Present, sir.
22 22
Present,
Salwa
sir.
23
Present, sir.
24
Present, sir.
25
Present, sir. Sorry. Sir, your mic is mute, sir.
Sir, your mic is mute. Hello, sir.
सॉरी डीन का फोन आ गया था तो मुझे डिस्टर्ब हो गया 826
Present, sir.
27
Present, sir.
48 80 20 29
Present, sir.
30
Present, sir.
31
Present, sir.
32 33
Present, sir.
35 835 Shubham Das
Sir, he left the university.
okay Shubham Das left the university
Yes, sir.
Yes, sir.
okay 36
Present, sir.
37 38
Present, sir.
39
Present, sir.
40
Present, sir.
41
Present, sir.
43
Present, sir.
45
Present, sir.
46
Present, sir.
48
Present, sir.
49 849 रितांकर विश्वास नहीं है.
No, sir.
50, 51,
Present, sir.
52, 52 अमन कुमार.
Present.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
57,
Present, sir.
59,
Present, sir.
60, 60,
अनन्या there.
860 नहीं है. 860
है
है.
sir. है.
Present, sir.
61,
Present, sir.
63,
Present, sir.
64,
Present, sir.
67,
Present, sir.
68,
Present, sir.
69,
Present, sir.
70, 70 प्रखर चंडेल. 71,
Present, sir.
72,
Present, sir.
75,
Present, sir.
76.
Present, sir.
जिन लोगों का रोल नंबर को हम ऑप्शन डाले हैं और एक बार बोल रहे हैं 2105746, 47, 73,
Present, sir.
Sir, 8.
73 है.
Yes, sir.
84, 801, 811.
Yes, sir.
811 है. हाँ.
Yes, sir.
818, 828, 835, 849, 870.
Sir, present. Sir, I got disconnected. I was there.
870, okay.
Yes,
तो
sir.
773, 811, 870 ये तीन जन का प्रेजेंट दे दिया और एब्सेंट है 746, 47, 84, 801, 818, 828, 835, 849. It's okay. So now onwards we will be progressing in the syllabus. We have no more time left. We have to do everything in detail. This week I am going to share to you, in fact, some of the study materials. Go through them carefully. Very soon there will be a quiz at the department level. Prepare for that. While reading, we will try to work out few examples then and there. You can try some examples from from internet, etc. connected to this, but not necessary to ponder over so many things. Your main motto is to understand the concept, visualize the situation, become technical, as well as, in fact, secure good mark in the final examination. As I have told you, if people are leaving, if they are not joining, they may be in problem, because whenever someone is leaving, that is getting recorded in my software. Okay. So as you people know, the total marks, 100 marks, is divided into two parts. One is internal evaluation part that consists of 50 marks. Another is end-sem exam that consists of 50 marks. Now, out of these 50 marks, there will be one mid-sem exam for which 20 marks will be devoted. The rest 30 marks that will be taken from assignment and quizzes. There will be 4 to 5 quizzes, maybe little more, and few assignments. Whenever we will be taking mark, we will take best 4. If there are 5 quizzes are conducted, we will take best 4 out of 5. If there are 3 assignments conducted, best 2 out of 3. So these marks will be taken together, added with the mid-sem mark that you have secured. That will be the total internal evaluation out of 50. After that, you will appear the end-sem examination. Whatever mark you secure in the end-sem examination, that will be added with the previous one, and the total will be taken in finalizing the grade. So you know how much you have to secure for what particular grade. Grades are in ranges that you know, particularly if you are having mark 90 or above, it is O grade, having grade point 10, and so on. So you must be understanding how CGPA, SGPA, all these things are calculated. Your tutor mentor must have apprised to you. You have already appeared one semester. Your result very soon is going to be published. I mean, by the end of this month, you will get, maybe by 20th of March, you will get your marks. Had there been no such cases of offline, online reporting, etc., your result would have been already, I mean, published. Because of all these phenomena and the faculties, etc., they are engaged in different activities. That's why copy checking process has been little bit late. So I hope you will get by 20 of this March, this month, the mark, I mean, the result of semester 1. And you must have learned something from that. You will try your best to remove the weaknesses and try securing good marks, because CGPA always matters in KIT University while going for the placements. Yeah, outside universities for higher study, etc. So you have to improve your CGPA. That's why you have to take care of all the activities. You see, if you are not going to secure at least 18 or 19 in midsem, then you are not going to get O grade in the final examination. That you must remember. So midsem, you be very careful. All the quizzes and assignments, you take them seriously and present your own. Don't copy anybody's, because that many times we pick up and we deduct mark for that. So I hope you all will be cooperating me in everything, taking the class, understanding. I will try my best to explain whatever I am teaching to you in the best possible manner. If you have any problem anywhere, you immediately ask there. You can stop me if it is not audible, the whiteboard is not clear. But if it is only at one student's end, then I cannot help. If it is the whiteboard is not clear to every student, then I will take care immediately. I may take pause for some time or whatever we will do. And one request I have, I may have to take, as you know, you have heard from your friends also, Visuals are used to take few extra classes. So because we will be discussing all these fundamentals in detail, so I may take few extra classes. Rather, I will tell you to go through your C language, etc., and see how these differential equations that we will be solving analytically, how they can be solved by using computers. Who can? How many of you who knows what a computer is? Let me ask you. All are going to be computer science engineers. So, how many of you really know what a computer is?
Almost
Yes.
everyone, sir.
Amish, bolo 767.
So almost everyone knows a computer is a mechanical device which is used to do calculations and all.
Why you say it is a mechanical device?
It is an electrical device which is used to perform calculations and all.
Calculations of what? Now you see,
Calculation of
before I listen your answer, because everybody, we all are listening. So let me make it clear. The whole mathematics is divided into two branches basically. One is algebra, another is analysis. Do you know what is done in algebra?
Yes, sir.
What is it?
Addition and all.
Addition, subtraction, multiplication, and division. You know, multiplication is the process of repetitive addition, and division is the process of repetitive subtraction.
Yes, sir.
Now, what you read in analysis? What you read in analysis?
Data handling and all.
Analysis basically deals with all those phenomena like derivative, integration. This part in mathematics is called to be analysis, and all these mathematical processes, they are taken in one place, that is called as computing. So computing in fact involves addition, subtraction, multiplication, and all other kind of operations, mathematical operations that you may have. And what gates are? In electronic devices, gates are actually the components who do the necessary processing. It may be derivative, it may be addition, it may be integration, it may be subtraction. You use some electronic circuit for that process, and that electronic circuit component you tell it as gate. Practically, if you look at the computer now, it is nothing but an electronic device who do all kinds of computing for you. Now, what is the principle of this computing? This device, particularly this computer, is an electronic device who does the computing process for you, starting from addition, subtraction to everything. So it does not have its own data. When you are when you are told to addition is a process. Addition does not contain data, but data are those on which addition process is to be operated. So addition is a type of operation. As long as data are not there, whom to you are going to add, subtract, multiply. So they are at the input end. What you provide, that is the data set. So through computing, you in fact do some analysis by a mathematical procedure using a computer device. So computer device, in fact, that's an electronic device and that cannot have its own brain. So you have to give some command to run one after the another. How these commands can be arranged so systematically in an organized manner that the computer with less effort can execute your process, your analysis in the best possible correct way. That is what you mean by saying algorithm. So practically computer is nothing but a computing device. Nothing but a computing device. Computing, when I say, I mean all mathematical operations that you have, who are to be operated on data set. So that's why to a computer engineering student, the data set and the computing processes, they are very, very important. First, the data set is to be stored at appropriate places, otherwise data will be missed. So for that, memory units are there, they are the part of the computers. Then there are the processes, there are the mechanism, there must be a mechanism who will pick up the right kind of data to operate on them properly so that the right kind of output you will get. So all these things, for that a processor is there who consists of so many different complex gates. So all these constitutes the computer. But practically, if you see, a computer is nothing but a complex electronic machine meant for the purpose of computing. You have to first understand what is the process of computing and what are minimum things that you need for the process of computing. It is very complex because your processor is so dynamic and your processor is so capable that it can simultaneously do so many things in a complex possible way. If I do 5 different tasks to you, you may feel tired. Your brain may not be functioning in that way when you will be doing one task only. But computer can do that. So practically, if you look at a computer, computer engineer does nothing. He only manages the computer to operate it in the best possible manner, storing the data, retrieving the data, operating on the data for a particular purpose. This is what you do. If you look at the geometry, mathematics, whatever you did in your physics, chemistry, even in your lower classes, they are everywhere. Computing is involved. You are suppose calculating the velocity of a body when it reaches to ground, when that body is left from a height. There also you are doing computing. You have some formulas, and these formulas computer cannot make. These formulas you have to establish. You can order the computer to work or operate in this according to the formulas that you have provided. So that's why the best possible way to handle the memory space, the best possible way to handle the processor, etc. That is what the main job of the computer students. If you look at it very broadly. Now, question comes, how these gates operate, how these processors operate, what are the basic principles of operation, because it is a device. So how that device works, what is the basic principle? As I will show you in physics here, the whole physics world can be divided into broadly 2 parts. One is classical physics, another is quantum world or quantum physics. Till now, the computers that you are using, who are working very fast and giving you the result desired in complex situations also within fractions of second, they all work on the principles of classical physics. That's why they all are called as classical computers. The computer that you are having now, very costly computer, very outdated computer that is provided by the KIT University in the form of a laptop, that is also a classical computer. But when the gates that you make, they work on the principle of quantum principles, principles of quantum physics, then what you get is a quantum computer. And this quantum computation, that means computation using the principles of quantum mechanics. First time, a great physicist, Richard Feynman, you might have heard about him, he is a Nobel laureate, he had this idea that yes, using the quantum principles, we can have a quantum computer who can do much more work than that of a classical computer in a very small time interval, in a more secured manner. So that is what now the biggest challenge to the scientific community is, to develop the useful quantum computers, those computers whose processors work on the principles of quantum mechanics or quantum principles. They are called as quantum computers. They have the input. You have a data set. They never provide the data set. You have a data set obtained from your observations. You are supplying them at the input. And their quantum processors, they do something on the data set so that your result, what you want to get, can be achieved in a very small time interval, in the most secured manner. Encryption is there. And while doing this, nowadays, physicists have seen, why I am saying physicists, because most of the computer engineers, they fear to enter into this. But before, little bit earlier, when I was telling you, I have discussed with so many computer engineers, computer faculties also, they used to say, now computer engineers or faculties, they may not be entering into this quantum computer era because they are afraid of this quantum physics, because it is having some fundamental principles which cannot be picked up if you are not giving some time for it. So they are saying, today we are managing everything with classical computers, but maybe 20, 25 or 30 years after, we have to work with quantum computers because we want to do everything in a secured manner as fast as possible, and in a very small space, we want large amount of data to analyze. So when you say I am having 1 terabyte memory, what do you mean by that? That means you have a very huge space in a very small physical space. Physical space, I mean the volume of nature, volume of the environment that it is accommodating. Huge space for memory, within that how much data you can store. With quantum computers nowadays, it is possible to store large amount of data in a very, very small space, and retrieving the data, manipulating the data, analyzing the data. This has become very possible. Very few companies are there like IBM, Google, etc., who have their own some, you can better say, some basic quantum computers. And many of the government, they are spending a lot. In fact, if you look at China, if you look at US, if you look at European countries, if you look at India, even 2018, India actually kept an amount of 8,000 crore only to do some research work and development in this regard for quantum computers, subletting the problems, actually take the money and do some research work and get some finding, build up some quantum computers. So nowadays, computer engineering, that's why have become very, very challenging, because things are to be done in a more effective manner, in a more secure manner, in a less time interval, very fastly. So that's why the job of the challenge in front of the computer engineer is very, very huge. And those who will be understanding properly how to do it, along with the physics, it will be very useful to them. Laterwards, they will be really leaders. So with this much of introduction, why physics is important to you, to computer engineers, I am returning to my topic. Particularly, I will advise you Even if you are not entering to the quantum computing in the near future, or quantum computers you may not be dealing with, but when I will be teaching you some of the topics like electromagnetism, of course, electromagnetism syllabus are at the very basic level, quantum physics also. But whenever I will be dealing with them, I will try to point out those basic principles, postulates, which are very essential in quantum mechanics and are useful particularly in the context of quantum computers. So I will point out these are the postulates, these are the principles which are very, very important in the context of quantum computer. If you in future are going to deal with such quantum computers, don't get afraid of. These are the things that you try to understand, visualize, and these things only will be applied there. The physics part, what I am telling you. So I am starting with the mathematical formulation of simple harmonic oscillation. I have taught you few things. I am starting from there. If you have any question to ask from the previous classes, you can ask before I start further.
No, sir.
No one has any question? Okay, then let me start. So I will be supplying the class notes, I mean, not the materials, study materials, not class notes. So my sincere advice is, whatever I am writing in the whiteboard, you please write them in detail in one copy, so that we get one. In this, on these dates are taught this. I will teach quantum, simple harmonic motion or oscillation with an approach which I have found to be completely different to many students than what they have approached simple harmonic motion or oscillation in their 11th class. My approach will be starting from the equations of motion, and why it is important that I am going to tell you, though I have explained that to you people earlier before the offline online concept was actually came into. Okay, I am just revising what is the meaning of this equation of motion. This is for your understanding, not a part of the note. But if you find it interesting, you can note. I am starting with a very simple case. Suppose a particle is moving along a straight line path. I want to discuss its complete motion. When I say I want to know its motion, what I practically want to know. When I want to know the complete motion, motion is a phenomenon. My purpose, being an observer, is to describe the phenomena, to discover the law that nature has fixed behind the phenomena. If you look at any natural phenomena, you will see that nature has fixed a basic law behind it. Look at any phenomena. So motion is a phenomena. There are few laws actually that govern the motion of all kind of motion phenomena, and they were first discovered by Newton. You know, in the famous Newton's laws of motion, there are 3 laws. You have read all these things. But when I say I am going to discuss motion, describe motion. Describing motion means what? पहले सवाल आता है ना, बच्चे लोग सोचेंगे मैं मोशन डिस्क्राइब कर रहा हूं, अरे क्या कर रहा हूं? पहला टास्क है फाइंडिंग द स्टेट ऑफ मोशन at any instant. ये पहला टास्क होता है. थोड़ा मैं ई की भर्ती कर लूं। और दूसरा जो टास्क होता है फाइंडिंग द स्टेट ऑफ मोशन एट एनी इंस्टेंट। तो ये स्टेट ऑफ मोशन का मतलब क्या होता है? इसका मतलब ये होता है कि whenever the particle is moving at any instant of time, what is its position? What is its velocity? The rate at which position changes? What is its acceleration? The rate at which the velocity changes? What is its momentum? The amount of motion contained in the body? What is the effort amount that is resulting the change in motion, that is force? What is the kinetic energy, the motion energy due to motion? And so on. There are many others. What?
सर वो दिख नहीं रहा है।
Yes.
सर वो दिख नहीं रहा है, राइट साइड में क्या लिख रहे हैं आप?
क्यों नहीं दिख रहा है? Let me
कैमरा
see.
का उत्तर सर view नहीं।
रुको 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 मैं चेक कर देता हूँ। सभी को नहीं दिख रहा है या तुमको खाली अकेला नहीं दिख रहा है बेटा?
सर कैमरा थोड़ा राइट कर लीजिए।
मैं देख लेता हूँ। एक्चुअली प्रॉब्लम तुम्हारे एंड पे है या मेरे एंड पे है, उस चीज को मैं देख रहा हूँ कि क्या हो रहा है। हाँ, ओके ओके ओके, अंडरस्टूड। Is it clear now?
यस सर।
Yes, sir. Yes, sir.
State of motion, what I want to specify. Actually, na, to specify the state of something, we in fact specify the state of some quantity, value of some quantity. पोजीशन क्या है, वेलोसिटी कितना है, एक्सेलरेशन कितना है, मोमेंटम कितना है, एनर्जी कितना है, फोर्स उसके ऊपर कितना एक्ट कर रहा है। ये सब बातें अगर ये सब चीज का वैल्यू अगर किसी पार्टिकल के लिए आप किसी इंस्टेंट के लिए बता दोगे तो आप बोलोगे कि हाँ हाँ हमको मोशन का स्टेट उस इंस्टेंट में पता है। इन वन लाइन, टू स्पेसिफाई द स्टेट ऑफ मोशन I need have to specify the values of some quantities. You see, quantities are something that can be measured. But what you practically measure when you measure quantities in physics? What you are measuring when you are measuring momentum? When you are measuring momentum in physics, you are in fact measuring the amount of motion contained in the body. When you are measuring velocity, you are measuring the rate at which the position is changing with respect to time. And all these things can be sensed. Everybody has 5 sense organs. तुम्हारा आंख, तुम्हारा कान, तुम्हारा जीभ, ये सब 5 सेंस ऑर्गन जो तुम्हारे में है, इस सेंस ऑर्गन को लेके जिस चीज को भी तुम सेंस कर पाते हो, जिस चीज को भी, उसको तुम फिजिकल बोलते हो। तो फिजिकल टर्म का मतलब ये होता है एनीथिंग दैट यू कैन सेंस। So whatever is physical, they can be categorized into 2 parts. One are entity, जो चीजें होता है, ये पेन एक एंटिटी है, आपका लैपटॉप एक चीज है, और कैरेक्टरिस्टिक्स या प्रॉपर्टीज। आप कैरेक्टरिस्टिक को भी सेंस कर पाओगे, आप एंटिटीज को भी सेंस कर पाओगे। याद रखना, ये कैरेक्टरिस्टिक्स प्रॉपर्टीज, किसका प्रॉपर्टीज, किसका कैरेक्टरिस्टिक्स? एंटिटीज का। एंटिटीज भी फिजिकल है, कैरेक्टरिस्टिक्स और प्रॉपर्टीज भी फिजिकल है। फॉर एग्जांपल मैं आपको एक एक्सक्लूसिव बात बोलूं, अभी प्रखर चंडेल, he himself is an entity, बट प्रखर चंडेल का जो हाइट है वो उसका एक कैरेक्टरिस्टिक है, और उस हाइट को भी हम सेंस कर पा रहे हैं और प्रखर चंडेल को भी हम सेंस कर पा रहे हैं, एंटिटी को भी हम सेंस कर पा रहे हैं और क्वांटिटी को भी सेंस कर पा रहे हैं। हम जब एक फेनोमेना में कोई भी स्टेट को स्पेसिफाई करते हैं तो कुछ क्वांटिटीज का हेल्प लेते हैं, उनको मेजर करते हैं, और जो क्वांटिटीज को हम लोग मेजर कर रहे हैं वो सब सेंसेबल कैरेक्टरिस्टिक को मेजर करते हैं। जिस कैरेक्टरिस्टिक या प्रॉपर्टी को आप सेंस कर पाते हो उसको मेजर करते हैं। इसीलिए वो सभी क्वांटिटी को हम लोग फिजिकल क्वांटिटीज बोलते हैं। सो व्हाट इज ए फिजिकल क्वांटिटी? एनी फिजिकल क्वांटिटी इज ए क्वांटिटी। क्वांटिटी मीन्स एनीथिंग दैट यू कैन क्वांटिफाई, anything that you can measure, that is a quantity. Whenever a quantity, when you are measuring, you are practically estimating a characteristic which can be sensed, then the quantity is said to be a physical quantity. Like mass, like length, time, temperature, pressure, volume, area, distance, speed, velocity, acceleration, work, energy, so many are there. So many physical quantities are there. And in fact, you never measure these physical quantities. You measure the characteristics or estimate the characteristics of entities. So entities are the systems and quantities measure their characteristics or properties. Every system is described by its characteristics or properties. When you say a system is in a particular state, you mean that the quantities which specify the characteristics, they have the fixed values. When I say the motion state of the particle is this, motion state of the particle is specified by specifying position, who has a fixed value, velocity, who has a fixed value, acceleration, who has a fixed value. But no entity in the universe can keep himself completely isolated. He has to interact with the surrounding. जितने भी सारे एंटिटीज दुनिया में देख रहे हो, वो सराउंडिंग के साथ किसी ना किसी रूप में इंटरेक्ट करते चलता है। बाहर से फोर्स आता है, हीट आता है, तरह तरह की रेडिएशन आके उसके ऊपर गिरता है। पत्थर एक बाहर है, उसके ऊपर सनलाइट गिरा, सनलाइट में फोटोन आए, फोटोन पत्थर के ऊपर गिरे, उसी के थ्रू में एनर्जी ट्रांसफर हुआ, तो पत्थर आइसोलेटेड कैसे रहा? कोई भी एंटिटी सराउंडिंग के साथ, एनवायरनमेंट के साथ कंटिन्यूअस इंटरेक्शन में रहता है, जिसके चलते जो क्वांटिटीज का वैल्यू उस सिस्टम का कैरेक्टरिस्टिक का मेजर करने के लिए हम लोग मेजर किए थे, वो क्वांटिटीज का वैल्यू भी चेंज होता रहता है टाइम के साथ। तो उसी को हम लोग बोलते हैं इवोल्यूशन ऑफ स्टेट विथ रेस्पेक्ट टू टाइम। मतलब स्टेट टाइम के साथ कैसे बदल रहा है, पोजीशन टाइम के साथ कैसे बदल रहा है, अगर बदल रहा है तो वेलोसिटी कैसे बदल रहा है, एक्सेलरेशन कैसे बदल रहा है, मोमेंटम कैसे बदल रहा है, काइनेटिक एनर्जी कैसे बदल रहा है, हाउ स्टेट इज इवॉल्विंग विथ रेस्पेक्ट टू टाइम। सो व्हेनेवर वी डिस्कस मोशन फेनोमेना, वी फोकस ऑन टू थिंग्स। वन, what is the state at a particular instant, the instant about which you may be interested, as well as you want to know how the state is changing with respect to time, how the state is evolving with respect to time. Now, do you have an equation or a set of equations or a set of equations? They can help you to get the state at any instant, or they can also help you to give the future state, the past state. That means they can tell you how the state of the system is evolving with time. If you have such an equation, you will say yes, I got an equation that can describe the complete motion for all time interval. That means using that equation, you can get the state of motion at any instant as well as any instant. State how it's changing with respect to time. That also you can describe by with the help of that equation. So if there is an equation that can tell you the state at any instant as well as how the state changes with time, both the things that the equation can give, then you will call it as the equation of motion. So equation of motion basically is that what gives you every information regarding motion. Not only the motion of state at a particular instant of time, but also you want to know how the motion state is changing with respect to time. And when you describe very clearly how the motion state is changing with respect to time, you say, I describe the type of motion. Suppose I say the particle is moving with uniform velocity. That means with the knowledge of the velocity now, I can easily say what will be the velocity after 1 hour, because velocity is more constant. So whatever velocity now is also the same at 1 hour after. Or suppose you are told that the particle is moving with a constant acceleration. That means if you know the velocity now, you can get the velocity after some time interval by using the equation v equal to u plus at. Because v equal to u plus at is the suitable equation for the particle moving with constant acceleration. So if you are able to describe the complete motion, so when I say complete motion, I mean I want to get the state at any instant that I want, as well as I want to know how the type of motion is. That means how the state is changing with respect to time. If all these things can be described by one equation, I will say that is the right equation to describe the complete motion, and hence that is the equation of motion. So in short, an equation of motion is an equation that tells you everything about the motion, not only the present state, but also about the future states of motion that are coming with respect to time, about the past states of motion that you can, that states who have already passed also can tell you how the motion state is going to evolve with respect to time. So up to this, if you could not follow any particular line or any concept, you can ask. What I tried to do is, I wanted to tell you what is meant by state of motion, what is meant by type of motion, and what is meant by equation of motion. Yes, any question? Anyone has any question if you are hearing me properly? Is it difficult what I am saying, or it is understandable?
Understandable.
Very
Yes.
good. Thank you. I hope you have understood because no one is asking anything. So now I am focusing some light on a simple example. Some more light. How to get the equation of motion? We understood what is state of motion, what is type of motion, and what is the meaning of equation of motion. That we understood in this discussion. But how to get this equation of motion for a particular problem? Because in nature, in different situations, the bodies may be moving differently, and accordingly the equations of motion may be different. So how to get the suitable equation of motion for a particular motion? I am taking a simple example of a straight line motion. Suppose this is the point which I have taken as the origin for position. So what an origin is? An origin is the starting point of measurement. I have taken this position to be the starting point of measurement. Now second origin I have to take is for time. I have a stopwatch. I have a stopwatch with me because I am an observer and I want to record the time also. So what I did, the moment I pressed the stopwatch, immediately that became t equal to 0. So that is the moment I press the stopwatch, that is the origin of time. Now after some time, the particle will have a position p. I want to look at this. What I will do? The procedure that you have adopted from your class 9, what you have done, you have measured the distance of that point p from the origin, let it be x, you say it is the position of is specified by the x coordinate. But as time goes on, as time passes, the position also changes. Now, tell me, can you have two different positions at the same instant of time?
No, sir.
No. Can you have same position at two different instants of time?
Yes, sir.
Okay. So you mean to say that one cannot have two different positions at the same instant?
Yes, sir.
You mean to say that one cannot have two different positions at the same instant? Say, Bhavya Priyadashini. भव्या तो कहाँ पे है?
रांची
रांची में है। भव्या अभी रांची में भी है और दिल्ली में भी है, सेम इंस्टेंट में। ये पॉसिबल होगा या नहीं होगा?
नो सर।
No, sir.
लेकिन ये तो पॉसिबल हो जाता है, ये तो पॉसिबल हो जाता है कि ऐश्वर्या राय अभी मुंबई में भी है और मेरे दिल में भी है।
Yes.
Yes.
So
Yes, sir.
how can one have not two different positions at the same instant? Now ऐश्वर्या मेरे दिल में है, ऐश्वर्या राय। तो
So
मैं
because
कैसे
other thing is an entity and it is other the first thing is
Yes,
an entity
yes,
and
that
then
is the
second
point. Very
thing.
good. That is the point. Aishwarya Rai as a physical thing is located at only one place at a particular instant. So
Yes, sir.
abstractly, she may be in my heart, but physically she can be at one position at a one instant of time. And in science, we always deal with the physical things because nature is something that constitutes of physical things, and in science, we are only interested about nature. Anything that is not physical is abstract. You can say abstractly, ऐश्वर्या राय मेरे दिल में है, तुम्हारा दिल में है और किसी का दिल में है, but that is not physical presence. Remember, in science, we are interested only about the physical phenomena, the physical existence, the physical properties, the physical quantities. Nothing abstract here we are going to incorporate. Yes, we may adopt some thoughtful thought models which are useful to reach at a particular conclusion. I mean, to useful conclusion which is related to physical things. But that does not mean that we are doing something abstract there. No. Abstract is something which cannot be, whose conclusion or whose result cannot be a physical thing. Any abstract phenomena cannot have a physical result. So whatever you are postulating, whatever you are having in your mind during the thought process to understand any particular physical phenomena to reach at a physical result is not an abstract thought. It is a model that you have developed in your mind to reach at a physical result. So this must you understand also. I'm going to discuss what the equation of motion is. What we discussed is at a particular instant there can be possibly one position only. So the relation is 1 to 1. Such relationships may be expressed as functions, as you have read in mathematics. Because at a particular instant of time, one can have one position only. So this satisfies the relation between x and t, satisfies the condition of function, and you can write x as a function of t. But saying this is not enough. Saying this only is not enough. You have to give the explicit form of this function. What do you mean by saying explicit form? A term many times explicit. In mathematics we use. When I say x is a function of t, I am accepting that x depends on t in a particular manner. But how? I do not know. But if I say x is equal to 3t square, here I specified exactly how x is depending upon t. The manner of dependence is specified explicitly. The dependence between x and t is explicitly shown here. So this is the explicit form of the function. Now, x can be a function of t like this, x can be a function of t like this, x can be a function of t like this. So there are many possible dependencies. Accordingly, the functions are categorized in mathematics, you know. This is what we call as trigonometric function, polynomial function, exponential function, logarithmic function. You know, you have categorized them in mathematics. Now, here in this particular case, all the particle moves, the position coordinate changes with respect to time, one to the one manner. That's why there is a functional dependence between them. The question is, can I get that functional dependence between x and t exactly, explicitly? There are two possible ways. First possible way is, what I shall do? I will record the positions at different instants. I am having a stopwatch with me. I am suppose having a sophisticated instrument using which I can record the positions exactly at different instants. So what I will do, I will record the position coordinate at some instant t1. Then at some other instant t2, what is the position coordinate and so on. I will have many such data. Yes.
So we have a BE class right now.
Oh, let me for a few minutes only. Okay, only 2-3 minutes. So if I give this data to the computer nowadays, computer can suggest me the best possible functional dependence between x and y. If I give this data, but it is very difficult to get these data very accurately. Suppose an electron is moving. With the best sophisticated instrument, I may not be able to detect the electron. And it is more difficult to locate the position of the electron exactly because at the level of electron, you know, Heisenberg principle comes into play, which says that electron's position you cannot determine with 100% accuracy. So this way, if you want to get the position at the time dependence during the motion, it many times fails. But second way, what is given by Newton is the best possible way. What Newton told, second way, Newton told that the force acting on a particle is equal to mass into acceleration. That you know. The particle that is moving may be electron, but you can easily measure its mass. That has been measured in 1901 by J.J. Thomson. Once he has measured it, you can keep it in your mind. You know the mass of the electron. It is not difficult to get the forces acting upon it. Very easy, because an electron can be deflected only by the electric field and magnetic field. And the electric field and magnetic fields, how much force they exert, that is very easy to measure experimentally. So from experiment, you can get F, you can get M. What A is? A is nothing but the derivative of velocity with respect to time, which is double derivative of position with respect to time. Then what you get? Force is equal to mass into d square xy with t square. What is this? This is a second order differential equation. You know the force, you know the mass. X is the dependent variable, T is the independent variable. With knowledge of force and mass, you can write this differential equation. Then in mathematics, you know how to solve this. If you solve this, what you will get? You will get x as a function of time. So I was telling you how to get x as a function of time. That can be obtained by solving this differential equation. And this differential equation is obtained from Newton's second. I will discuss more things later on in the next classes. Any question from your side before I start?
No, sir.
Okay, then you have class, so I am stopping here. Your questions are always welcome. Please try to understand properly. Thank you all.
Thank you, sir.
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 Thank you.